All right, so hopefully after working all the way through, so same thing, this one's a little more complicated because we got -1 plus delta x. We squared that out. We simplify all of our terms all the way through, and we got 2. Hey, now you're probably like, Mr. Darbone, what are we doing? This is so confusing. Okay, let me warn you here. We're going to do this notes, and we're going to learn this limit definition of a derivative, but we're really not going to stick with it. We're learning it. You need to be able to recognize it, but it's not that big of a deal. It's not a big thing. It's not something that we're really going to worry about. Okay. So with that being said, from this equation, so this was our slope of a tangent line. They then decide, you know what that slope of the tangent line really is? That is the derivative. Okay. So the slope of the tangent line is the derivative at a specific point. But we can generalize the derivative as an equation that gives us all the slopes. So we say f prime of x, which is the derivative, is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Yeah, that's the exact same equation. All they did is stuck this in and said, well, this is also equal to the actual derivative. Okay, the other way that they write this, and this is my preferred way, but I show you both because you could see both on the AP exam, the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. All they do is replace delta x with h. It's the same equation, but delta x is kind of annoying to write, and it gets confusing with regular x, so they replaced it with h to make it a little bit more simple to understand. Okay, but this is the limit definition of a derivative. Let's talk about that term derivative a little bit more. Okay. So the derivative is an equation, okay? Let's just make that very clear. When I say find the derivative, you are finding an equation, and that equation is f prime of x. That gives us a slope along f of x for all of my x values. So going back to our parabola example, my derivative is an equation that would give me all of these slopes along my parabola. So at any point, I could find the slope if I have the derivative. Okay, what we did right here is we found the slope at a very specific point. Okay, but my derivative equation can give me the slopes at all of my different x values. So it's really more useful to find the equation of the derivative than it is to just do this whole process to find just a specific slope. Okay, so this process of taking the derivative is called differentiation. Okay, so what we're doing is we are differentiating when we are finding a derivative. Now, some different notations, some different ways that you can see the derivative written. Of course, we have our f prime of x, the one we just did there. Okay, you could do y prime. So any function, whatever it is, you just tack f prime onto it, it means the derivative. You could see dy over dx, which means the derivative of y with respect to x. Okay, kind of think about like y is your dependent, x is your independent. Still kind of transitions through. And then you could see this ddx of f of x. This is really fancy notation, which just means to take the derivative of f of x. So it's kind of telling you to derive, okay, but it's another way to denote the derivative. Okay, so let's actually apply it. Let's find a derivative function. So we're going to find the derivative of f of x is equal to x squared plus 2x using the limit definition of the derivative. Okay, so we have the limit as h approaches 0. I prefer h. You can use delta x, but h is just so much easier. So we have the limit as h approaches 0 of this first piece is my f of x plus h. So everywhere where there's an x in my equation, I'm going to replace it with x plus h. So x plus h squared plus 2x plus h. Okay, minus f of x, so minus x squared plus 2x all over h. Okay, now I got to simplify it a bit. So this is equal to x plus h squared. Just FOIL that out and you get x squared plus 2xh plus h squared. Then distribute the 2, so plus 2x plus 2h minus x squared minus 2x. That's all over h. Okay, before we move to the next step, let's see if there's anything we can cancel out. Negative x squared and x squared cancels out. Negative 2x and positive 2x cancels out. So now we get 2xh plus h squared plus 2h, all divided by h. What you might notice is you should get, from this step to here, all of your terms should have h in them. That is your goal, because then I can cancel an h out of everything, and that gives me the limit as h approaches 0 of 2x plus h plus 2. I plug in my 0. Ooh, that's a terrible 0. And then I get my final equation. Two x plus 2. So f of x is x squared plus 2x. F prime, which that is a bad prime, is 2x plus 2. Okay. Notice how they're really similar equations. We're going to talk about that a little bit more later, okay? But I do want you to be like, wow, those are really similar and easy, okay? So that's a big mess, but f of x and f prime of x, notice how similar they are. We're going to come back to that a little bit, okay? Number 3, given f of x equals 2x squared minus 3, we're going to find the derivative, we're going to find the slope, and then we're going to find an equation to represent the tangent line. We'll get to that one at the end, even though you're like, Mr. Arbone, I don't know how to do that. We'll talk about that. Okay. So finding the derivative, we're going to plug it into our limit as h approaches 0. So the limit as h approaches 0 of 2x plus h squared minus 3 minus 2x squared minus 3 all over h. FOIL and distribute, that would give us 2x squared plus 4xh plus 2h squared minus 3 minus 2x squared plus 3 all over h. We should get a bunch of things that cancel out. So minus 3 plus 3, negative 2x squared, 2x squared. So once again, something you should notice, all these terms in the end should cancel out in that first step if you're doing this correctly. So that becomes 4xh plus 2h squared over h. Cancel out our h's. That gives us the limit as h approaches 0 of 4x plus 2h. Plug in 0. We get 4x plus 2 times 0. And that gives us f prime of x is equal to just 4x. And that's our part A. Okay, now part B, we want to find the slope at 1, 2. Now previously, we plugged it into our big long equation to find the slope. But now, we're not coming back to that anymore. Now, I have an equation for the derivative. The derivative is an equation that gives me the slope at any x value on f of x. So I can take that x value and plug it straight in. So B, f prime of 1 is equal to 4 times 1 which means my slope is equal to 4. Nice and easy. Much easier than that. Okay. So now, last step, step 3, I want to write a tangent line equation. Well, a tangent line equation is a line, so I'm going to be writing the equation of a line. Okay. My tangent line, as we talked about up here, is a line that represents the slope. So I'm going to be using the slope. I want the tangent line equation at this point. So I want an equation of a line that's going to have slope and it's going to have the point. Well, we have this super awesome thing called our point slope equation of a line. Y minus y1 is equal to m x minus x1, with y1 and x1 being the values of the point, m being the value of the slope. So I can just plug all those things in. So y minus 2 is equal to 4 x minus 1. And because we are super lazy mathematicians, I'm not even going to solve for y. I'm going to leave it right there. Make our life easier. Okay, that is the limit definition of the derivative.